In today's lesson, we'll be talking about the properties of circles. If you recall, we've already learned the general equation of a circle, which is x squared plus y squared equals r squared. Remember, x and y represent any point on the circle, while r represents the radius of the circle. Here are the key concepts for today's lesson. You can review these on your own. I'm going to focus on this concept. The right bisector of a chord of a circle passes through the center of the circle. Here's a diagram of a circle. You should be familiar with these already. That would be called the radius. That would be called the diameter. And we have another feature of a circle. Let's say I have 2 points on the circle, one over here and one over here. The line segment that joins these 2 points is called a chord. So a chord is a line segment that connects any 2 points on a circle. As mentioned beforehand, the right bisector of a chord will pass through the center of a circle. So let's say I have these 2 points. I'm going to connect these 2 points. That would be called a chord. Now I'm going to draw a right bisector. A right bisector is going to intersect this chord at a 90-degree angle, and it's going to cut this chord exactly in half. That's why it's called a right bisector. It is also going to pass through the center of the circle. That's really important. So this is called a right bisector. You may also know this as a perpendicular bisector. These are synonyms. You can either refer to it as a right bisector or a perpendicular bisector. They mean the exact same thing. In our first example, we want to verify that the line segment from P to Q is the same length as the radius of the circle x squared plus y squared equals 365. In order to figure out length between 2 points, we need the length equation. We already know that. We want to figure out the radius of the circle x squared plus y squared equals 365. The radius is somewhere within this equation, but it is not entirely obvious. So we're going to have to break this down a little bit. So I'm going to rewrite the equation which is given, x squared plus y squared equals 365. If you recall, the general equation of a circle, which is centered around the origin, is x squared plus y squared equals r squared. X squared is the same thing as x squared, y squared is the same thing as y squared, while 365 is equal to r squared. Let's go ahead and make a note over on the side. Therefore, r squared is equal to 365. Now, to figure out what r is, we need to get rid of this exponent of 2. To do that, we will square root both sides. Square root is the opposite of raised to the exponent of 2. So that exponent of 2 is going to disappear, and you're going to be left with 365, the square root of 365. I'm going to leave it as is for the moment. Now that we've figured out the radius of the circle, let's figure out the length between points P and Q. I'm going to move this a little bit, and let's write down the general equation for the length between 2 points. I'm going to give this a subscript of PQ. The rest of this equation should be pretty simple. You've used it numerous times. Before we substitute in our values, let's go ahead and make life easier for ourselves. We have 2 coordinates. Let's label this x1 and y1, and let's label this x2 and y2. That makes life a little bit less confusing. So in our next step, I'm going to substitute in these numbers. So I'm going to write substitute in point P, which is 4, -2, and point Q, which is -9 and 12. I am going to write out all the work for this question. So I'm going to substitute in these values. When I do, I'm going to put them in brackets. I'm going to clean up the stuff in the brackets, and you will be left with -13 to the power of 2 plus 14 to the power of 2, and that will be all under the square root sign. That should be 169, and that would be 196. Again, we're going to simplify whatever's under the square root, and you will be left with 365. Let's interpret the information we've just calculated. We've figured out the radius of the circle, and that is the square root of 365. We've also figured out the length between points P and Q, and that is the square root of 365. We can now write a therefore statement. Therefore, the length of line segment PQ is equal to the radius of the circle. In our last example, A and B are points on a circle centered at the origin. We want to verify that the right bisector, in other words, the perpendicular bisector of chord AB passes through the center of the circle. Like I've said in previous videos, a good idea would be to start with a rough sketch if you've been given enough information. Let's go ahead and do that. So I have a blank Cartesian plane, and I'm going to do a rough sketch. So point A is 1 and 7. So that is point A. Point B is 5 and 5, which is right over here. According to the description, these 2 points lie on a circle. I'm going to try my best to sketch a circle freehand. It's going to look something like that. There is a chord joining points A and B. I'm going to draw it in. Now, we want to figure out if the right bisector of this chord goes through the center of the circle. In other words, does it go through the origin? Let's do a rough sketch here. So that would be the right bisector. Since it cuts the chord in half and it intersects it at a 90-degree angle. Let's label some of these points so it's a little bit easier for ourselves. I'm going to call this C, and I'm going to call this point D. There are different ways of doing this question, but I'm going to tell you my strategy. I want to figure out the general equation of this right bisector. In order to do that, I need to find 2 things, its slope and its y-intercept. Its slope can be figured out from the slope of AB, since the slope of AB and this right bisector are negative reciprocals. I can figure out point C. Point C is the midpoint of chord AB. Once I have the slope and once I have a point on the line of the right bisector, I can find its equation. Once I have the right bisector equation, I can substitute in any point into this equation and do a left side equals right side check to verify that that point actually exists on that line. I know that sounds like a lot of steps, but let's go through that together. Let's start by finding the slope of AB. Now, just like before, I'm going to go ahead and label these points so that's a little bit easier for myself. I'm going to label this, let's say, x1, y1, x2, y2. After I've done that, let's go ahead and find the slope of that line. Slope of line AB, that is the chord, is y2 minus y1 over x2 minus x1. That should be fairly simple. That's going to be 5 subtract 7 over 5 subtract 1. That calculation is going to be pretty simple. That's going to be negative 2 over 4, which simplifies to negative 1 over 2. Since chord AB is perpendicular to the right bisector, that means their slopes are negative reciprocals. So let's write that down over here. Since chord AB, and let's just call this line CD instead of calling it a right bisector. Let's say line CD are perpendicular, therefore their slopes are negative reciprocals. Let's sum that up over here. So the slope of CD is just positive 2. Afterwards, we want to figure out what the coordinate of this midpoint is. What is the coordinate of C? Let's go ahead and do that. I'm going to say midpoint of AB is equal to x2 plus x1 over 2, and then y2 plus y1 over 2. At this point, you can just substitute in these values. So I'm going to write that in. I'm going to say sub point A, which is 1 and 7, and point B, which is 5 and 5. That's going to be 1 plus 5 over 2 and 7 plus 5 over 2, which gives you 3 and 6. I've done some of the steps in my head. Let's go back to our diagram and fill in some of our information. We know that the slope of AB is negative 1 over 2, which makes the slope of this right bisector, I'm going to call this CD, positive 2, since they are negative reciprocals. I've also just figured out the coordinates of C. The coordinates of C are 3 and 6. If you refer back to the diagram, you'll see that your answer of 3 and 6 seems pretty reasonable as compared to the grid lines that are behind this Cartesian plane. Now that we have the slope of our right bisector and we have a point on our right bisector, we can find the Y-intercept. Let's do the work down here. We're going to start with the general equation of a line in slope-intercept form. Y equals mx plus b. You want to substitute in the values you just figured out. So you want to substitute in the slope of the right bisector, which is 2, and a point on the line, which is c. That is the midpoint we just figured out earlier. Let's substitute in those values. That goes in brackets. That goes in front. The 3 goes in brackets. Everything else stays the same. At this point, it's just a matter of simplifying and isolating b. To get rid of the 6, you have to subtract 6 from both sides. A lot of you can do this in your head. So that just becomes 0. And 6 minus 6 cancels out. The b stays the same. I like to read from left to right, so I'm going to flip this so it reads b is equal to 0. So we've just figured out the y-intercept of this right bisector, which happens to be 0, which means it goes through the origin. It goes through the center of the circle. You could stop here, but I'm going to go to the next step, and I'm going to see if the center of the circle, 0, 0, fits on the line. And we're going to do a left side equals right side check. At this point, we know the slope of our right bisector, and we know its y-intercept, so we can write its equation. Let's do that down here. We're going to start with the general equation of a line in slope-intercept form, and I'm going to say sub the slope of CD, which is 2, and the y-intercept of the right bisector, which we just determined to be 0. That is going to make it y equals 2x plus 0. And you should know that you don't want to write that 0 in, so it's just y equals 2x. That is the equation of the right bisector. Let's update our diagram over here. So the equation of the right bisector, we just determined that to be y equals 2x. To see if this right bisector passes through the center of the circle, which is the origin, we need to see if that point satisfies this equation. Let's go all the way back down here. And I'm going to write instructions. Sub the point 0, 0 to see if point lies on right bisector. That should be pretty straightforward. Let's go ahead and do that. That y is going to be a 0, and the x is going to be a 0 as well. And you're going to see that left side is going to be equal to right side because both sides are equal to 0. Let's zoom out to see all the work that went into this one question. It should be microscopic by now. Let's write a therefore statement. Since left side equals right side, therefore the right bisector passes through the center of the circle.